With 92 international publications, he has authored 4 books, 9 book chapters, and holds 2 patents. Dr. Dheeraj Singh has guided 7 PhD students, organized 4 conferences, delivered 45 invited talks, and reviewed over 100 research papers. He is also a DOS member at multiple universities and a life member of several professional societies. So, let's welcome Dr. Dheeraj Singh. Sir, over to you.
Thank you for the nice introduction. First of all, I would like to thank Dr. Rahul ji for inviting me to deliver a talk in this prestigious workshop. So today I am going to discuss about the surface enhanced Raman scattering, a nanoscale tool for healthcare application. I will also try to show the application of enhancement in your Raman signal in sensor application and healthcare application. I don't know how many people know about the Raman effect, because it is very important to know the Raman effect. Then I can come surface enhanced Raman. Okay, Raman spectroscopy including with nanomaterial known as surface enhanced Raman scattering. So before coming to search, I will first describe about the journey of Raman spectroscopy. Then I will come in very small nanomaterial and what happens if we combine nanomaterial and Raman spectroscopy. A new technique was generated, we call it surface enhanced Raman scattering, which can be highly applicable in pharmaceutical industry, medical industry, sensor industry, and medical reform. A lot of instruments actually detected by. So I will try to explain all these things. So I have divided my presentation in 6 distinct points. First of all, I would like to describe saga and development of Raman and surface enhanced Raman. Then I will describe why Raman spectroscopy and surface enhanced Raman spectroscopy is so special, and how the information we can withdraw from this Raman spectrum from any molecule, material, coronavirus, everything, virus, disease, how we can detect, how we can sense, even nuclear waste material, uranium, from the solar, soil, water, and how we can detect explosive element like RDF, TNT in a very small amount, trace amount. We can also find out by Raman spectroscopy. So generally we can get the information in Raman spectroscopy on 3 different parameters. Wave number means frequency of the molecular vibration, second is line width, third is intensity variation. So I will describe after that application of first 2 various application, sensor and healthcare application. And I also try to give a knowledge about the technology transfer of this type of instrument rule in Viksit Bharat 2047. Nowadays means a lot of portable devices has been built in order to sense the molecules, material and healthcare application based on this. Nowadays, you know that Raman got the only Nobel Prize from the India. Only one physicist got the Nobel Prize in India in 1928. He got the Nobel Prize. After that, no Indian got the Nobel Prize. So nowadays, more than 25 variants of the Raman spectroscopy has been developed. Nowadays, very recent technology is called as tip enhancement Raman, TERS. We are talking about today's search only, but now advanced level TERS tip enhancement means it will addition of STM and SCRS. Means scanning tunneling microscope plus surface enhanced Raman scattering give a new technology known as tip enhancement Raman. So now we can make a portable Raman device like this small thing and make a detecting of any particular material like explosive element or any other element. So spectroscopy, because surface enhanced Raman scattering. So what is the spectroscopy? Actually, idea of spectroscopy was originated in 1600th century by the simple experiment. You know that Sir Isaac Newton. Actually, he is the originator of the spectroscopy, because you know that white light when comes into through the prism. Have you remember in high school you have performed some experiment? White light comes into the prism, Now this print disperse the white light into 7 colors, which they are red color, violet color. You can see that. So what is the meaning? Meaning is that white color already have 7 color in their wavelength. So dispersive means our print only separate out all the color, means they have 7 color, we cannot see it, but this medium disperse all the 7 color. So this process is known as spectroscopy, means light matter interaction is known as spectroscopy. So light and matter can be any type, solid, liquid, gas, your molecules, coronavirus, disease, anything, bacteria, all are molecules. Every material are made by atom. Atom are connected by chemical bond, and chemical bond are vibrating at picosecond order. And Raman spectroscopy and IR spectroscopy give the information about that particular molecular vibration level. Now you can imagine any DNA, any protein, any biomolecule, any R&D, RDF, TNT, uranium, all are connected by chemical bond. That's why we can get the information during that chemical bond structure and sensitivity. So what happens when light incident on light have photon, electromagnetic radiation interact on any molecule, solid, liquid, gas, then what happens? Either your light can be absorbed by the molecule, either it can be reflect, either it can be scattered. So everything, your light is absorbed, so we call it UV absorption spectroscopy. If your light is scattered, we call it Raman effect, because Raman is a scattering process where light coming and interact with your molecules or material. Now light will be scattered in all the direction. We can gather the scattered radiation through the sensor like a CCD, charge coupled detector. It will sense the light. And what happens? Means now light giving the every information about your molecules and material. Without affecting anything, light is only source. Light are scattered हो गया, ये light carrier of the information of that particular molecule and material. And this is identified. That's why in forensic laboratory, forensic science, Raman have a lot of application also in order to solve the criminal offense. Because Raman gives the identification of the material, molecule, chemical identification, like DNA fingerprint. Our fingerprint will be different, your different. So Raman spectroscopy clearly identifies that particular difference because of content of that particular material. So now we are interested in only Raman spectroscopy. A lot of spectroscopy has been developed because of this behavior absorption. IR light, you know that infrared light is incident on any molecule material. If IR light is absorbed by the molecular vibration, we call it IR spectroscopy. IR and Raman both are giving similar information. We call it complementary technique. But Raman is a absorption process. Sorry, IR is a absorption process. Raman is a scattering process. This is the difference. And then more difference, IR change in dipole moment required, or Raman change in polarizability in the molecule are required. In IR, water molecule can be interfere and give the broad spectrum in IR. But in Raman, water will not interfere. That's why Raman has highly applicable for biological molecule. You know that human body, almost 80% chemical reactions are happening in water environment. Is it? 80% water environment. So it means that biomolecule or biochemical reactions can be only applicable by Raman spectroscopy in majority. That's why Raman has a lot of application in biological field, medical field, rather than chemical or physical field. So fluorescence spectroscopy, magnetic resonance MRI, you know that magnetic resonance NMR, magnetic photoluminescence, fluorescence spectroscopy, all are branches of spectroscopy. But only what is the information you are getting by the light, it is known. So I am only interested to scattering of the light from your sample, which are Raman. This is a complete description. Means what is the type of light you are using? It decides the type of spectroscopy. Simplest example, you can see that if you are using the radio wave, you know that radio wave is very less frequency. Radio wave, if you are applying any molecule material, the radio wave will give you information about the spin oriented in magnetic field. And this technique, now in this technique, instrument has been developed, we don't call it NMR, nuclear magnetic resonance. So this instrument not only applicable for only physics, chemistry, bio or engineering, every field you can see that. Now suppose you are using microwave light. By frequency you can see that frequency is different in wave number centimeter or wavelength. You can memorize in any term. If your microwave light is coming, now it will only sensitive for rotational, molecular rotational. You know that every molecule material has electronic state. In electronic state there is a vibrational state, molecule vibrating. In vibrational state there is a rotational state. So now in this rotational state, molecule rotation can be identified by microwave light. So microwave light comes into the molecule, it is giving the rotational information, and the technique has been developed. Instrument का क्या नाम है? Electron spin resonance. ESR, EPR, all these are instruments which are already developed on this concept. Now we are coming in this range. If we are using infrared or visible light, visible light का मतलब क्या है? Red, green, blue, whatever we can color we can see. This is the visible range. Now you can see that visible range is coming to 400 to 700, 650 nanometers. Okay. So now what happens? If you apply any mid IR can be divided in three parts: mid IR, near IR, and far IR. If you are applying any visible light or infrared light on every molecular and material system, then what happens? IR light will be absorbed by the molecule and give the IR spectra, and Raman light, मतलब UV, IR, any light you are sending in the molecule, now molecule vibrations will change in the presence of light and it will scatter. Scattering, Raman is a scattering process. Whatever light is scattered from your sample, we are going to analyze that particular thing. And it will give you all the information. It will give every information about your molecules and material, structure, dynamics, sensing property, identification, every information. So Raman is a scattering process and giving all the properties about the molecule. So I am coming to only this part here. So molecular vibration means IR light is giving information about molecular vibration. The technique has been developed, IR spectroscopy. And IR and Raman both are giving similar information, so Raman and IR giving the UV, valence, X-ray, gamma ray, nuclear science, high frequency of energy actually we applied from the nuclear material, so we call it gamma ray. Gamma ray. X-ray, you know that X-ray light. XRD भी जानते हैं? X-ray diffraction, X-ray, XPS. Have you heard about the XPS? X-ray photoelectron spectroscopy, which worked on the basic principle of photoelectric effect. Einstein got the Nobel Prize in 1921 something about the photoelectric effect. So in that particular technique now XPS is a very costly instrument and a very informative instrument for every material, whatever molecule material in every field. I hope everybody researcher actually use XRDs, Raman, IR, UV, XPS, same, TAPE, NMR in their research. So time is limited, so I am coming to very fast on the basic part because my motive is to come in surface enhanced Raman and their application in sensor and healthcare. But it is mandatory to inform about Raman effect because without understanding Raman, you cannot understand the surface enhanced Raman. That's why I am making. So types of molecular vibration, every molecule vibrating in different frequency. And frequency can be divided into. आप देखें होंगे Raman या IR में जो peak आता है, you can see spectrum means x-axis and y-axis information. X-axis is wave number. Sometimes Raman shift also written and y-axis has intensity. Okay. So that particular peaks are coming due to the some vibrational feature of the molecule. Every molecule, every large molecule, biomolecule, every pharmaceutical drug molecule have chemical bond vibration. तो हमको जो peak मिलता है Raman IR में, that is some chemical bond vibration. Our first task is to identify that assignment. We call it vibration assignment. So vibration assignment can be fundamental or non-fundamental. Stretching, in stretching मतलब रबर की तरह. कोई bond अगर vibrate कर रहा है ऐसे स्प्रिंग की तरह, we call it stretching vibration. And in stretching there are two type of vibration. Symmetric, if both atoms are coming together, we call it symmetric stretching. Antisymmetric, if one are coming outside and one are coming inside, this type of vibration called is antisymmetric. Actually these are happening in every molecule that material at picosecond level. Water देखते हैं H2O, that water has also molecular vibration. And Raman and I give the structural information using that vibration. Same way, every molecule, DNA, protein, any virus, any disease, all have molecules and they have some particular molecular vibration. Like in amino acid, like protein can be divided by various amino acid. Amino acid, you know, the cysteine, arginine. Okay, so now people will refer to that particular amino acid. So all information you can get, I am not think. Now a lot of vibration you can see that in plane vibration, out of plane vibration, we can give a name. Twisting vibration, rocking vibration का मतलब इस rocking ऐसे करेगा. Scissoring vibration मतलब कैसी लेते हैं, कैसी यूज करते हैं, तो जैसा वाइब्रेशन हो रहा वैसा वाइब्रेट कर रहा मॉलिक्यूल हम बोलते हैं तो सीजरिंग वाइब्रेशन. एंड एवरी वाइब्रेशन हैज डिफरेंट फ्रीक्वेंसी. हम 10 लोग हैं, 10 लोगों के ऊपर रमन आया, सबका आइडेंटिफिकेशन अलग आएगा. मीनिंग इन एनी मॉलिक्यूल there are carbon, hydrogen, nitrogen, oxygen, sulfur. Every atoms are there and they are binding, electronic binding are different. कार्बन सल्फर से अलग तरीके से बाइंड करेगा, ऑक्सीजन के साथ अलग तरीके से करेगा. एंड फ्रीक्वेंसी mu is equal to 1 upon 2 pi under root k by mu. It means mu is directly proportional to 1 upon under root m mass. तो क्या हुआ, फ्रीक्वेंसी mu is the frequency is directly proportional to 1 upon m. मतलब मास ज्यादा है तो फ्रीक्वेंसी कम होगा और मास कम है तो फ्रीक्वेंसी. That's why every Raman IR different peaks are observed from different sources. CO का अलग पीक आएगा, CH का अलग आएगा, CN का अलग आएगा. हम बताते हैं कि ये CO का है. That's why we can apply Raman spectroscopy for unknown substance. Unknown substance means you have collected some molecules or rocks from anywhere, from ISRO or space. You can detect any molecule, collect it and take the Raman IR data. So we can expect that कि इसके अंदर क्या क्या है. 1500 में पीक आया तो हम बोलते हैं तो CO है इसके अंदर. 2200 पे आप बोलेंगे C ट्रिपल बॉन्ड ये अवेलेबल है इसके अंदर. That's why ISRO scientists actually claim that in space this molecule, existence of this molecule was proved. तो लाते हैं, देखते हैं. Like microwave spectroscopy also important. So I am not coming much more detail about this. This type of vibrations actually we are coming. Suppose this is the simplest example I give you. Water now. Water is H2O. Okay, 2 hydrogen, 1 oxygen, and these are not linear molecules. This is bend molecule. So now in bend molecule you can see that there are number of vibrations will observe 3n-5 or 3n-6. N is the number of atom. कितने atom है यहाँ? 3 into 3 minus. If your molecule is linear, so 3n-5 number of vibrations will be there. If your molecule is non-linear, so 3n-6 number of vibrations will be there because of degree of freedom. I am not coming to that. But you have to remember water has 3 atoms, 2 hydrogen, 1 oxygen. So 3 into 3 minus 6. That is 3 vibrations will be obtained in Raman and IR spectra of water molecule. तो वही वाइब्रेशन में दिखाया है. One is कैसा वाइब्रेशन है? बेंडिंग मोड. तो 1600 सेंटीमीटर इनवर्स, 1600 frequency always known as bending mode vibration of water molecule. And second peak is coming at this more than 3600. We call it OH stretching. आप देखिए, this is oxygen, this is hydrogen, दोनों एक साथ जा रहा है. क्या बोलते हैं इसको? सिमेट्रिक OH स्ट्रेचिंग. उसके बगल वाला एंटी सिमेट्रिक स्ट्रेचिंग. तो वाटर, नाउ माय मोटिव इज दैट दिस इज द Raman spectra. You can see that this is the Raman spectra having the x-axis frequency, y-axis intensity. So means bending vibration give a peak at this position, this peak giving this position, this position. Now suppose any drinking water had mercury content, because you know that accumulation of mercury in our body cause the cancerous cells in our body, lung cancer and something like that. Because World Health Organization WHO gives some limit of detection, limit of your particular hazardous element in our body. आप सुने होंगे लेड जो है टॉक्सिक होता है, मरकरी भी टॉक्सिक होता है, पानी पीने अगर मान लीजिए उसमें माइक्रोन लेवल का भी है तो धीरे धीरे बॉडी में क्या होता है, एक्युमुलेट होता है, आफ्टर सर्टेन ईयर इट विल कॉज द कैंसरस सेल. तो इट मीन दैट हाउ यू कैन डिटेक्ट, अगर इसके अंदर प्योर वाटर के अंदर मरकरी है तो यू नो व्हाट हैपेंस, दिस स्पेक्ट्रम पीक विल बी डिफरेंट. अगर इस 3 पीक के अलावा किसी भी वाटर में कोई और पीक आ रही है, इट मीन दैट देयर आर सम कंटामिनेंट, देयर आर सर्टेन impurity available in your sample, because Raman gives the identification of the water molecule. थोड़ा भी चेंज है, 3 पीक के अलावा चौथी पीक आई, it means that there are some impurity mixing in their sample. Mercury is binding with water, immediately you will get some certain peak change, either with light will change, either with frequency will be shift. तुरंत क्या करेगा, रमन बता देगा कि there are certain problem. I will show you pure pearl, उसका रमन स्पेक्ट्रा लीजिए, प्योर पेर्ल का सेम है, अगर उसके अंदर इम्प्योरिटी है तुरंत उसका स्पेक्ट्रम चेंज हो जाएगा. यू कैन आइडेंटिफाई लाइक कैंसरस सेल, इफ यू आर टेकिंग द रमन ऑफ द हेल्दी सेल, it will be different. If you are taking the Raman spectra of cancer cell, spectra origin will be different. Means you can identify that this is the cancer cell or a healthy cell by Raman spectra, because origin of, because cell is also made by a molecule, and that particular peak give you information about that. A lot of these type of variations are there. We celebrate National Science Day on 28th February because of the discovery of Raman effect in India. That's why we celebrate Science Day on this discovery of Raman effect. How did the idea come to mind? I am not coming because time is limited. So when he was visited Europe, in Europe they got the idea and discussed their research with Rutherford and a lot of scientists in Europe. And how the idea come? Actually, one day he was visiting Mediterranean Sea and see the beautiful blue sky of the sea. So he was aware about that. Relay who already got a Nobel Prize in 1921. Relay already told that the blue color of the sea is just a reflection of the blue sky. होता है, आसमान ब्लू है इसलिए उसका रिफ्लेक्शन जा रहा है, समंदर ब्लू दिख रहा है. But Raman was not agree, not convinced this explanation about the relay. He returned back to India, and this journey of Europe actually made revolutionize the field of science from the India. So he got the Nobel Prize with his PhD student K.S. Krishnan after applying a lot of experiment on available molecules. पहले उन्होंने मॉलिक्यूल में देखा कि उन्होंने क्या क्या लाइट भेज रहे हैं, हर बार मॉलिक्यूल का स्पेक्ट्रा अलग आ रहा है. तो he was confused. First time he thought that कि ये कुछ impurity की वजह से आ रहा है. But when he repeated a lot of experiment, बेंजीन, CCl4, लैब में जितने केमिकल था सब किया, तो उन्होंने देखा कि ये तो ट्रेंड बता रहा है, सबका एक आइडेंटिफिकेशन बता रहा है. तब उन्होंने एक पेपर जो भी लिख के भेजा, न्यू सेकेंडरी रेडिएशन ऑफ लाइट इन नेचर पब्लिकेशन. बट दैट टाइम एडिटर हैज रिजेक्टेड दैट पेपर. Editor has rejected. This theory looks very ridiculous, not very real. But reviewer rejected. But editor read that thing and he published his research in own risk. और 2 पेज का पेपर पब्लिश हुआ नेचर में. Now that 1931 he got the Nobel Prize. Now after 1931, now this field of Raman spectroscopy has been revised. You cannot imagine, रमन का 25 से ज्यादा इंस्ट्रूमेंट बन गए हैं, पोर्टेबल डिवाइस बन गए हैं. ऐसा कोई एरिया नहीं है जहाँ इसका एप्लीकेशन ना हो. कोई भी एरिया आप बोलेंगे, सॉइल से लेके इलेक्ट्रिक से लेके मशीन से लेके कार्बन बेस्ड नैनोमेटेरियल लाइक ग्रेफीन, कार्बन नैनोट्यूब, फ्लोरीन, क्वांटम डॉट, विदाउट रमन यू कैन नॉट कैरेक्टराइज. तो दिस इज अ डेवलपमेंट. In 1977, surface enhanced Raman spectroscopy has been developed. I will come in what is the Raman. Then application I have told you, unlimited application in every area. There is, first I am saying what is the Raman effect. Suppose this is your molecule. This is your any molecule, solid, liquid, gas, drugs molecules or any material. Now suppose any light is incident on your molecule. So what happens? If light having energy h at omega or h nu, both are similar word. If incident on your molecule's material, then what happens? If the scattered radiation has same frequency as the incident radiation, we call it relay light. Relay scattering. Relay से पहले से मालूम था. These things were already known. It was not discovery. Now what happens? If the scattered radiation has less energy than incident photon, less energy than incident photon, we call it Stokes process. Stokes का नाम क्यों आया? Stokes वाले scientist who already told that in fluorescence if frequency is coming, अगर molecule के बाद frequency कम scattered होगा तो we call it Stokes shift. Stokes shift का मतलब whatever energy is there you are incidentally, now energy is less than that incident photon, we call it Stokes process. क्यों कम हुआ? Because light gives some energy or light gives some energy to your molecule. Molecule vibrate कर रहा है, अब ये light अपना energy कुछ दिया, तो we call it Stokes process. And anti-Stokes process, if your scattered radiation has larger frequency than incident radiation. Now the finding of this Stokes and anti-Stokes, finding of this Stokes and anti-Stokes line is known as Raman effect. I hope everybody knows about the Raman effect. Raman is scattering, finding of Stokes and anti-Stokes. क्योंकि relay पहले से मालूम था. They have found this two, and Stokes and anti-Stokes are equally spaced on the Raman line. Whatever paper you are seeing Raman spectra, that position Raman shift is Stokes process, because Stokes has less frequency but larger intensity, and we need to record larger intensity in the Raman effect. So all the Raman shift are Stokes process. Okay. So classical theory was failed. I am not coming because the time is running. Quantum description, quantum physics explain the Raman effect. I think most of the people are not from physics or chemistry, so I am not coming to describe the Raman effect in scientifically classical physics, electrodynamics or quantum physics term. Okay, I hope now you understand the Raman effect. Simple is a class. Scattering process, light is scattered from a molecular sample and give the Raman signal. In terms of spectra, this is the Raman process. So this thing I will quit because time is. This is the Raman spectrometer, where here your microscope is there, sample you can put here. Any liquid, solid, gas, whatever material you can put here, light is coming interior and it will go to it. And as I told you, please disperse into 7 colors. Similarly, here light is coming, scattered. Now it will go to monochromator. Now there double monochromator, triple monochromator are built in the spectrometer instead of fridge. Fridge पहले 1600-1700 का था. अब नया डेवलपमेंट हुआ, उसकी जगह monochromator, like double monochromator, triple monochromator है. It will separate out the Raman signal at different peak, and through the CCD charge command detector you can record the spectrum. This is the Raman signal. If you are getting any Raman peak, then you can give frequency in x-axis, intensity y-axis, and this is the line width. So line width, frequency, and this is intensity. Give the information about your molecular system. Every information. या तो frequency shift होगा, change होगा, if you are adding some nanomaterial or adding any molecular interaction between two. So what happens? Either frequency will be shift, either line width will be changed, either intensity will be varied. So you can achieve all the information about your system by these three different parameters. So this is another vibrations. I am coming application of surf, Raman and surf. Application, you can see that application is unlimited, from fundamental material science, food analysis, forensic science, biological application, environmental, environmental sensor, everywhere application. This is the application, whatever I can show you, Raman spectra different of pure pearl, and this is the short pearl. This is the pure pearl. If you have Raman spectra coming in the same thing, we call it pure. If apart of these three peak, you are getting a lot of so many peak in the Raman signal, we call it forgery. Some impurity are mixed in your sample. This is just indication. ऐसे ही आप कर सकते हैं healthy cell, Raman cell and cancer cell, because healthy cell have different content of of P and cancerous cell have different content of P. Like Demu and कभी-कभी करते हैं simultaneous detection of Demu virus and corona virus. तो डेंगू वायरस का पीक अलग आएगा और इसका अलग आएगा. तो we can identify sensing that. Fingerprint of molecule, as I told you, every person has different fingerprint. If you are taking the Raman structure, every peak will be different. Every person has different Raman fingerprint. Identification means, अब देखते होंगे फोरेंसिक साइंस में उन्होंने गिलास पे बोले कि उंगलियों के निशान लेते हैं. मैच कराते हैं, क्यों लेते हैं? क्योंकि सबका उंगलियों के निशान अलग आएगा. Same way, Raman spectrum gives the signal every fingerprint for different person. Means Raman gives the identification of every person in different. It means Raman spectroscopy are highly applicable in sensing in forensics. As I told you, more than 25 variants has been developed on the Raman. I have worked also a lot of part of the Raman, but it is not good time to explain everything. But now I am coming to Raman to first only. Okay? Otherwise, other things I have. So now I am coming to surface enhanced Raman. What is the meaning of surface and why is surface enhanced Raman required? You know that Raman, simple Raman, we call it normal Raman. Simple Raman spectroscopy in Raman is a weak process. Weak process means only one photon is scattered out of 10 million photon. 10 million से केवल एक photon scattered होता है. It means Raman is a weak signal, but fortunately, in the presence of nanomaterial, the signal of your Raman will be significantly enhanced. Up to 10 to the power 12 times, signal can be enhanced. If you are calculating the atomic radius, 10 to the power 12 times means that you are going to detect single molecule or single bacteria or single वायरस. सिंगल का मतलब क्या होता है? पहले लोग चावल पकाते थे. हाउ नो दैट राइस इज कुक्ड? वो क्या करते थे? एक राइस निकालते थे, एक राइस पक गया तो मतलब पूरा राइस पक गया. तो सिमिलर वे सिंगल मॉलिक्यूलर डिटेक्शन है इंपॉर्टेंट बिकॉज इफ यू अंडरस्टैंड द प्रॉपर्टी ऑफ सिंगल मॉलिक्यूल देन यू कैन मेक ए ओवरव्यू ऑफ बल्क मॉलिक्यूल. Okay, that's why single molecule detection is important. And now surface enhanced Raman scattering increase the signal up to 10 to the power 12 times. It means that we are able to detect single molecular information in surface enhanced Raman. In simple word, I am saying surface enhanced Raman is equal to Raman plus nano. Raman plus nano, giving same information, but with high sensitivity. क्या करते हैं? I am giving example. Suppose terrorists have used terrorist attack on civilian. तो आप देखते हैं फोरेंसिक वाले आते हैं ब्रश से सब डाटा कलेक्ट करते हैं. ओके, तो रमन सिग्नल यू कैन नॉट टेक फ्रॉम द वन सैंपल और 10 सैंपल. एक सैंपल भी एक छोटा सा पाउडर भी आया तो रमन कैन गेट सम डिफिकल्टीज टू आइडेंटिफाई. बट जैसे आपने नैनो बनाया, नैनो का मतलब समझ रहे हैं? 10⁻⁹ मीटर डायमेंशन, एवरी मेटल कैन बी कन्वर्टेड टू नैनो. So I am not coming to nano explanation about the nanomaterial. There are bottom up top down approach to synthesis of the nanomaterial. Every material can be shrink into 10⁻⁹ meter resin. We call it nanomaterial. Due to surface activity, highly surface activity, it have a lot of application. So nanomaterial थोड़ा बहुत सुना होगा नाम ना. So now what happens if you make the nanomaterial substrate like metal nanoparticle, silver, gold, copper? If you make the metal nanoparticle using some chemical reduction method, now you can put your signal, whatever things you have detected from the terrorist point, RDS है, TNT है, उसको क्या करेंगे? एक दश से आपका सिग्नल नहीं आ रहा रमन, but when we put this sample at the place of nano substrate, जैसे ही nano substrate पे रखेंगे, you can get the Raman signal. Meaning is that without affecting any property of your molecules and material, nanomaterial enhance the Raman signal. So enhancing in the Raman signal, why the nanomaterial is known as surface enhanced Raman spectrum. Are you getting the point? नैनो क्या करता है? आपका एक डस्ट है, उसको रखिए, आपका सिग्नल आने लगेगा. पहले नहीं आ रहा था जहां सिग्नल, नैनो only enhance the signal. That's why it was called surface enhanced Raman. Now, if one dust is there, you can put and you can detect. I will give some example and application. There are two types of mechanism: electromagnetic enhancement, chemical enhancement mechanism. So this is the basic fundamental principles, basic physics principle. I am not coming. I will coming to explanation about the application part. Application are in forensic science, like Raman spectroscopy of body fluid. Suppose you can characterize that whether your blood is dry or wet, or how much old your samples are there, blood samples. You can see that here wet and dry Raman samples are identified by 115 and 1511. मतलब ये पीक है, इसको बोलता है रमन मार्कर बैंड, रमन मार्कर पीक. This peak actually gives the information whether your blood is wet or dry. Or here EDTA wet, EDTA dry. EDTA means where the sample where you can collect it. Here dry blood and dry semen. That is the differentiation about the Raman spectroscopy. And the particular peak, these two or three peak only identification, give the clear identification for the particular material. Now detection of fluor nitrogen in medical industry or healthcare industry, it is very hazardous. Sometimes generally this fluornitrogen is well known as a death drug, for files or the food with colorless odorless, because it is colorless, odorless or tasteless. So that's why criminals can mix this chemical a very small amount in alcohol, like rum, vodka, whiskey. This is all the variety of wine. If small quantity are mixing in that particular thing, you cannot identify because it has colorless, odorless and particular thing. But how we can identify what type of drug they have mixed and what quantity has been mixed? You can detect, you can sense by Raman spectroscopy. This is the example. Means if these two peaks are identification of volume percent. अब देखिए कितना परसेंट है. अगर आपने उसको नैनोमोलर में भी मिलाया है, nanomolar 10⁻⁹ molar solution is mixing in your any particular wine or certain places, not only wine, only liquid or certain places you can identify, you can sense. कैसे sense करेंगे? This peak should be come in the Raman, then you can find out. So what is the volume percentage? Still you can sense this thing and solve the criminal cases. Detection of explosive on truck. हमने बोला कुछ टेररिस्ट अटैक हो गया, कहीं में हमको कुछ नहीं मिल रहा है, किसी के शर्ट पे एक भी डस्ट भी मिल गया शर्ट पे, तो यू कैन टेक द रमन स्पेक्ट्रा बट नॉट गेटिंग. तो आप क्या करेंगे, एक डस्ट ला जाके नैनो सबसेट में उसको ड्रॉप कर दीजिए, रख दीजिए. देन रमन सिग्नल लीजिए. रमन क्या करेगा, एक डस्ट का भी सिग्नल बढ़िया से देगा और इनहार्म सिग्नल. दैट्स व्हाई रमन सरफेस इनहार्म रमन गिव द. मतलब अगर एक डस्ट को आप पानी में घोल दीजिए, 10⁻⁹ मोलर कंसंट्रेशन को भी पानी में घोल दीजिए, उसका रमन लेंगे तब भी वो बताएगा कि इसके अंदर आरडीएक्स है कि यूरेनियम है कि मरकरी का कंटेंट है, यूजिंग दैट पर्टिकुलर पी. ओवरऑल वी आर गोइंग टू सेंस दिस पर्टिकुलर मटेरियल इन दिस पर्टिकुलर ट्रेस अमाउंट. वी कॉल इट ट्रेस अमाउंट. फूड एनालिसिस, large fat, butter fat, you can identify. Like many cases you know that many दूध में लोग क्या मिलाते हैं, आजकल लोग बोलते हैं यूरिया मिला देते हैं. यूरिया मिलाते हैं दूध में. जैसे ही आप दूध प्योर मिल्क का रमन स्पेक्ट्रा लीजिए, आईआर लीजिए एंड यूरिया कंटेंट मिल्क का लीजिए, तो यूरिया NH2 CONH2 का कंटेंट दिखने लगेगा स्पेक्ट्रा में. यू कैन आइडेंटिफाई इमीडिएटली विद इन 2 मिनट कि दे हैव मिक्स्ड यूरिया इन योर सैंपल और नॉट. केमिस्ट्री वाले भी बता देते हैं यूरिया का भी एक सैंपल सिंथेसिस होता है, लैब में डालते ही बता देंगे यूरिया है. ओके, so you can identify that particular food analysis. What is the content, what is the impurity, what type of impurity has been mixed in your sample, because it is directly connected to health. Sensing application. Now I am coming surface enhanced Raman in sensing application. Surface enhanced Raman means Raman with nanomaterial can detect explosive element. Explosive element can be RDF. RDF जानते क्या है? RDF TNT, trinitropoluene. You can see this is the trinitropoluene. This is the molecule. Molecule are binding by the chemical bond radiation. This is the TNT explosive element, and this is the RDF. RDF जो बोलते हैं सब chemical नाम क्या है? Cyclotrimethyltrimone. So this is the RDF. This is the trap. So terrorists use any and these are molecule, and molecule are there means they are going to detect. कैसे डिटेक्ट करना है? Anywhere, a one powder or any liquid powder you can detect. I will show you. First task is to make a nanomaterial. Since my motivation is not to describe the nanomaterial, so I am not coming to synthesize the nanomaterial. But after synthesis, making the nanomaterial substrate, हमने nanomaterial बना लिया, gold, silver, copper, graphene, quantum dot. Every material can be made in nanomaterial. जो भी बना लिया, उसके ऊपर इसको trace amount रख दीजिए. Trace amount मतलब अगर water में है, water में तो one drop इसके ऊपर nano के ऊपर खाली drop कर दीजिए. Different concentration you can see. How it is a sensor? How RDS can be sensed? पहले हम क्या करेंगे? 10-3 मोलर हमने ड्रॉप किया, रमन स्पेक्ट्रा रिकॉर्ड किया, सिग्नल आया, सिग्नल किसका आएगा? RDS का आएगा. Because nanometer only in half the signal without affecting any property. तो सिग्नल RDS का आया, 10-3 में पीक आया. आप क्या करेंगे? कंसंट्रेशन और घटाइए, 10-5 करिए, 10-9 करिए, 10-12 करिए. कहां तक रमन पीक आ रहा है? अगर 10-12 मोलर तक पीक आया और वही RDS का पीक आया तो आप क्या बोलेंगे? कि our Raman spectrum sense the RDS in 10⁻⁻12 molar. 10⁻12 molar is a very small quantity. मतलब nanomolar, picomolar concentration presence of RDS can be detected by Raman spectrum. हम यही है, कैसे दिखाते हैं यहाँ पे भी. तीनों का यूज है एक साथ है, रमन तीनों को अलग-अलग क्यों बताएगा? Second thing is sense कहाँ तक कर रहा है? बोलते हैं limit of detection. Because World Health Organization gives some limit कि कितना amount हम mercury body में ले सकते हैं, lead ले सकते हैं. How much amount? It can be defined by WHO. तो nanomolar तक people are trying to sense any molecules and material until nanomolar. Nanomolar. तो limit of detection मतलब कितना तक हम sense कर पा रहे हैं. This is the thing. This is the nanomaterial substrate. It is a nanosynthesis process. I am not coming much detail, but we can see that here when we are taking the Raman spectrum, they are transformed some molecule, they are some nanometer. But when we put some molecule in that particular the Raman signal is started to come, and there are certain peaks which are responsible to detect that particular thing. Like here, TNT, TNB, DNT. Three are very similar type of molecule, like methanol and ethanol. अंतर क्या है methanol ethanol में? C2H5OH और एक C4H6OH. दो एटम का डिफरेंस है, but Raman spectrum give clear differences between two spectrum because of their mass and electronic structure. So you can identify between two close molecules. That's why this slide shows that difference between TNT, TNB, TNB by this peak. By this peak you can identify whether what type of explosive element they have. Like TNT, RDS, these are explosive element. You can see that they have taken spectra from here to here. जहाँ तक इन्होंने कंसंट्रेशन कम करते गए हैं, यहाँ पे आप देखिए पीक आ रहा है. मतलब ये पीक अगर आएगा, पोर्टेबल डिवाइस आपने बनाया, रमन इज ए पोर्टेबल डिवाइस. सपोज आपने नैनो पे जैसे RDS रखा, लाइट को इसको डाला, पोर्टेबल डिवाइस ये आपका सिग्नल बता देगा. आपने देखा कि ये पीक आ गया, दिस पीक आर बोथ ऑफ पीक आर कमिंग एट पर्टिकुलर पोजीशन, इमीडिएटली आप बताएंगे कि RDS. Portable device, just you have to put on the sample. That spectra means identification of peak gives the clear identification. और रमन कैसे बता रहा portable device? Because you are using nano substrate. nano का वहाँ पे environment है. इसलिए आपका जो आ रहा है tip enhancement रमन. Tip enhancement रमन is a combination of surface enhanced रमन plus scanning tunneling microscope (STM). अब क्या कर रहे हैं? टिप enhancement में वो बना हुआ ऑलरेडी टिप है, मॉलिक्यूल रखिए, आपको तुरंत सिग्नल सिंगल मॉलिक्यूल का बता देगा इंफॉर्मेशन. सिंगल मॉलिक्यूल का मतलब कुछ भी आप कहिए, बैक्टीरिया डिवाइस, कुछ आप बैक्टीरिया कहिए, कोई वायरस कहिए, डेंगू वायरस कहिए, आप कोई फार्मास्यूटिकल ड्रग कहिए, ग्लूकोज कहिए, सबको डिटेक्ट कर देगा. वो बताएगा कि नहीं ये है. ओके. Such another method to make the synthesis of nanomaterial called nanomaterial play important role in the sensor of any material in Raman. So first task is to make the nano. You can see one example here. That is the background. BG means background spectra. In background spectra मतलब हम direct ले रहे हैं, कुछ नहीं आ रहा है. That is the clarity कि the signal is coming from molecule. हमने यहाँ पे देखिए This spectra is coming from 10 minus 7 molar. This is a blue. Blue का मतलब 10 minus 7 molar TNT explosive element आपने मिलाया कितना 10 minus 7 molar. The peaks are coming. कौन सा पीक आ रहा है? This is the identification marker Raman band. अगर ये पीक आ रही है तो आप बोलेंगे कि TNT है इसके अंदर. हम कंसंट्रेशन घटा रहे हैं 10 minus 7, 10 minus 9, 10 minus 12. कहाँ तक आया है? This peak are coming until purple में 10 to the power minus 11 में. पीक आ रहा है मतलब कि this molecule or explosive element are sensed until this concentration. तो हम बोलते हैं limit of detection of this explosive element is picomolar concentration. यही हुआ बात ना. अब अगर आपको बहुत ही कम क्वांटिटी में वाटर में भी TNT रहेगा तो आप ये पीक अगर आया तो आप बता देंगे कि TNT है. Okay, so nuclear waste material like uranium oxide is the nuclear waste material, and in the soil, कभी nuclear attack actually होगा nuclear weapons you are making, but nuclear radiations are there, nuclear material can be disposed in the land. So what happens? In earth, in soil, your uranium contaminant is present in your water. Water के अंदर contaminant है, uranium oxide is the source of uranium, UO2. अब वाटर के अंदर सोर्स आप पी रहे हैं उसके अंदर यूरेनियम है कि नहीं, हाउ यू कैन डिटेक्ट? बिकॉज़ बाय एक्युमुलेशन बाय नैनोमोलर और पिकोमोलर इन ह्यूमन बॉडी कंटिन्यूअसली आफ्टर सेवरल इयर्स, आफ्टर 2 years, आफ्टर 10 years, इट विल एक्युमुलेट इन आवर ह्यूमन बॉडी एंड कॉज द कैंसरस सेल. तो क्या जरूरत है हमको? वाटर जो पी रहे हैं उसमें देखते हैं कि यूरेनियम है कि नहीं है, तो उसको कैसे दूर किया जाए? तो यूरेनियम यू कैन आल्सो डिटेक्ट बाय द नैनो मटेरियल एंड रमन सिग्नल. And Raman signal is at 730 to 790 centimeter peak. If this signal are coming in Raman, immediately we can say that uranium oxide means uranium content present in your sample. Means it will sense the uranium which at the particular molecules are liquid, and you can detect as a sensor. So we are now you can say serve as a sensor of uranium. And second, limit of detection कितना तक किया sense. Second is environmental health के लिए भी ये important है, because if you are sensing the particular material, then you can get that particular. This is a tap water. How you can detect? This work actually I have published in Journal of Hazardous Material when I was doing postdoc in South Korea. So here I have also detected one hazardous element called citrinine. Citrinine is a very toxic element. I hope some biological person know about citrinine. It was very toxic. Environment में या नाक में जाने बहुत टॉक्सिक है. तो हम लोगों ने इसको बहुत ज़्यादा सिल्वर नैनो पार्टिकल पे काम किया. तो हमने डिटेक्ट किया, हमने बताया कि कैसे साइक्लिन को डिटेक्ट कर सकते हैं सर. सेल में कैसे सेल में अप्लाई कर सकते हैं. रमन इन बायोमेडिसिन, दिस इज द हेल्दी सेल एंड कैंसर सेल रमन स्पेक्ट्रा. You can identify whether your cell is healthy Raman or this is dengue infected bronch serum and non dengue healthy serum. दोनों स्पेक्ट्रा अलग आ रहा है. डेंगू एंड नॉन डेंगू. अभी आप जाते हैं डेंगू का टेस्ट कराते हैं, डेंगू का टेस्ट होता है कि मालूम चलता है. अगर इफ यू आर मेकिंग ए पोर्टेबल डिवाइस, रमन डिवाइसेस, एंड यू आर अप्लाइंग स्मॉल क्वांटिटी ऑफ ब्लड, immediately 2 minutes, within 2 minutes device can give the information about the dengue and non dengue things. It is highly important and applicable. This is another viruses identification. This is the example of nanomaterial synthesis, UV visual absorption characteristics. And now you can see that cancer serum, there is no absorption coming in cancer, pure Raman cancer. Cancer का हम जैसे Raman signal ले रहे हैं, कुछ peak नहीं आ रहा है यहाँ पे. But when we put this molecule on nano substance, silver nanoparticle, immediately signal, Raman signal started to come. तो मतलब क्या हुआ? Nano material enhance the Raman signal and you can detect the cancer cell very easily by the Raman. That's why we call it surface enhanced Raman. This is the molecule detected by normal Raman spectra, and B is the breast cancer cell. Cancer cell, again, a lot of tests are there, mammography and something like that to identify the breast cancer. But what happens if you are taking the Raman spectra? You can see there is no any signal. But as soon as we mix the nanomaterial, the breast cancer cell which Raman signal can start. So we can detect breast cancer cell very early stage using that particular portable Raman device. This is the coronavirus. Everybody knows the coronavirus structure. Biological person know very well. E protein, glycoprotein, and a lot of structure are there. And without understanding the structure, we cannot predict their property. If you understand the structure, then you can predict their property. तो पहले क्या हुआ? पहले टेम आप देखेंगे टेम इमेजेस ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपी इमेज गिव द सिमिलर क्राउन टाइप स्ट्रक्चर. तभी आप स्ट्रक्चर देखिए. आप कोरोना मूवी आई थी ना वैक्सीन वार, उसमें देखिए एक टेम में दिखा रहा था टेम का स्ट्रक्चर भी कैसा दिख रहा है. गूगल पे भी देख सकते हैं. तो मींस पीपल फर्स्ट क्या करते हैं? पहले हम इसका स्ट्रक्चर जानेंगे. विदाउट अंडरस्टैंडिंग स्ट्रक्चर यू कैन नॉट मेक द वैक्सीन, यू कैन नॉट प्रिपेयर द मास्क. पहले क्या जानेंगे इसके जो ई प्रोटीन एस प्रोटीन ग्लाइकोप्रोटीन ये जो स्ट्रक्चर इसको वो कैसे तोड़ना है. तभी आप लोग देखें मेरे कोरोना वायरस में लोग रब कर रहे थे एल्कोहलिक सॉल्वेंट से. एल्कोहल से करते थे ना. एल्कोहल कैन एबल टू ब्रेक दैट पर्टिकुलर लेवल. अगर आपको पता नहीं है कि एस प्रोटीन ई प्रोटीन उसके बाहरी लेवल पे क्या है, पहले पता चला स्ट्रक्चर पता चला, देन वी कैन मेक अ सैनिटाइजर टू कैन बी ब्रेक दैट पर्टिकुलर. Second thing, what is the size of nanomaterial? Corona virus. अभी हम गए थे I was interview. I asked a lot of biological people for RA position interview. कोई नहीं उसमें 8-10 बच्चे से कोई नहीं बता पाया what is the size of it. Because corona has some size in more than 300 to 400 nanometer. अगर आपको साइज नहीं पता तो आप मास्क कैसे बनाएंगे? अगर साइज इसकी 2 नैनोमीटर है, आप मास्क पहन के चल रहे हैं माइक्रोन लेवल का, वो असर करेगा? कुछ नहीं करेगा. तो फर्स्ट टास्क इज टू मेक द स्ट्रक्चर. व्हाट इज द साइज आप लोग को लगा है. हम जान के साइज 400 नैनोमीटर का और हमारा मास 200 नैनोमीटर को रोक लेगा. देन वी कैन यूज दैट पर्टिकुलर मास. तो मीनिंग इज दैट स्ट्रक्चर हैज डायरेक्ट कनेक्शन टू प्रॉपर्टी एंड विदाउट अंडरस्टैंडिंग स्ट्रक्चर वी कैन नॉट प्रेडिक्ट प्रॉपर्टी. यू कैन नॉट मेक द वैक्सीन. हियर यू कैन सी दैट Raman can give clear identification about the identification. This is the signal of the virus. So Raman give this green signal. ये green दे रहा है. Green is coming from this signal, this part, and blue are coming from this part, and this green. So mean what is the part of it? Because protein, glycoprotein, this is a molecule, and Raman give the signal. So this peak are corresponding to that particular thing. अगर एक साथ 3 वायरस डालेंगे तो Raman clearly identified these are dengue virus or corona virus. A technique has been developed, virion has been developed to, I am not coming to how to it work, but any viruses can be detected, sensed at the very small amount. Use an application, I can say Raman have a lot of application. Recently, last year I have published one book with my collaborator Professor Alumni Relations in Germany. So this is a very nice book we have published and included all the chapter based on Raman spectroscopy. It started from very first chapter I have written, very small historical development of Raman and basic principle instrumentation and application. Then a lot of good chapters have been introduced by pronounced scientists from all over the world. Germany, Japan से जो बड़े-बड़े scientists एरिया में काम करने वाले हैं उनका भी contribution इसमें है. If anybody have interested, you can read. Nanomaterial because they have also important application. I have also published this book in 2023. You can also read. So technology transfer I am not coming to that time when you go. Right? What is that? Okay, 2 minutes I am doing. Now you can see that we understand the Raman with nanomaterial known as surface enhanced Raman. So now a lot of portable device has been developed. Moore's law, electrical engineering के ज़्यादा लोग हैं कुछ लोग. Moore's law, you know that. What is the Moore's law? पहले इंस्ट्रूमेंट बहुत बड़े-बड़े होते थे. एक पूरे कमरे बैठा होता था. छोटे हो गए. अभी ATR I have also purchased some project in IIT and there is a ATR 4 to 5 kg का है. आप डेली घर ले जा सकते हैं. But giving every information without sampling preparation, solid, liquid, gel, every information you can achieve. So meaning is that now our first task to make all this concept in portable devices. अगर हम छोटा सा डिवाइस बना लिए and putting the particular thing सिक्योरिटी में वहाँ पे हमने रखा, हमने चेक किया, हमने ब्लड थोड़ा सा ब्लड लिया, उसको डाला, देखा कि डेंगू है कि कोरोना है. अगर ये बता दे रहा है हमारा छोटा डिवाइस 2 मिनट में, कितना मतलब बढ़िया होगा. तो people are making and many devices has been developed on the basis of portable devices for sensor application and healthcare application. कि कैंसर सेल है कि नहीं है, अभी तो मेमोग्राफी कराना है, देखते हैं कितना लंप है क्या है, लेकिन बट दिस सिग्नल यू कैन नाउ एज ए टिप इनहांसमेंट करना सर्फेस इनहांस प्लस एसटीएम। एसटीएम जानते हैं स्कैनिंग टनलिंग माइक्रोस्कोप, बहुत हाईली रेजोल्यूशन एटॉमिक रेजोल्यूशन का इंफॉर्मेशन देता है। तो दे आर मिक्सिंग एंड दे आर सिंगल मॉलिक्यूल डिटेक्शन यू कैन आल्सो डिटेक्ट। टेक्नोलॉजी ट्रांसफर इन लाइफ साइंसेज, यू कैन सी recent background technique UP PCR keep repeat they can use life sciences technology can be transferred in life sciences application. Portable device, what types of information you want you can collect. Advanced surgical imaging with Raman spectroscopy. Raman has a lot of application surgical instrument as I told you. Any type of surgical endoscopy, you know that endoscopy हम क्या करते हैं, इंडोस्कोपी में वो रॉड डाल के फाइबर डाल के देखते हैं पेट के अंदर क्या गड़बड़ तो नहीं है, कहीं खून तो नहीं निकल रहा है। नाउ रमन स्पेक्ट्रोस्कोपी गिव्स द क्लियर आइडेंटिफिकेशन अबाउट दैट। टेक्नोलॉजी ट्रांसफर इन एग्रीकल्चर फूड सेफ्टी इट इज नॉट पार्ट ऑफ आवर लेक्चर, तो आई एम स्किपिंग दैट। पोर्टेबल रमन लीड क्लीन सेंसर फॉर रैपिड डिटेक्शन ऑफ प्लांट। टेक्नोलॉजी ट्रांसफर इन बॉर्डर सिक्योरिटी। बॉर्डर सिक्योरिटी हमारे जो सैनिक है वो आजकल मांगते हैं, डीआरडीओ का साइंटिस्ट आप डिस्कस करेंगे, दे आस्क कि हम लोगों के लिए ऐसा एक इंस्ट्रूमेंट बनाइए, हम लोगों के लिए ऐसा बनाइए कि हम लोग कभी-कभी एक महीना भूखा रहते हैं, आपको याद होगा कुछ टैबलेट बनते हैं वो खा लेते हैं, उनको भूख नहीं लगती है, ठीक है, बिकॉज इट इज रिक्वायर्ड। उनको चाहिए कि हमको ऐसे ऐसे इंस्ट्रूमेंट चाहिए, पोर्टेबल डिवाइस चाहिए जो हमारा सिक्योरिटी में काम आए, ड्रोन चाहिए उनको। तो यू कैन पीपल आर डिजाइनिंग that particular border security and a portable Raman spectroscopy devices like reactive property QR border security have been developed. So enable scanning for transfer packaging and detect, identify and verify chemical thieves, narcotics, explosives and hazardous material. Reduce exposure risk of security personnel provided rapid, non-destructive or real-time vision. Non-destructive means this instrument are not harm your material or non-destructive without affecting any property it will detect. आपने देखा किसको डिटेक्ट कर रहा है मशीन, एक्सप्लोसिव एलिमेंट कोई भी हो डिटेक्ट कर लेगा सेंसर, हजार्डस एलिमेंट डिटेक्ट कर लेगा, weapons any हजार्डस मटेरियल मतलब कोई भी हजार्डस एलिमेंट आ गया, केमिकल आ गया, you can detect by the portable method. This is the method handover for forensic analysis. You can see that this instrument has been developed for the forensic application. Or this application space achieve Viksit Bharat. You know that Viksit Bharat road not only science, technology, development also has been a lot of Viksit Bharat mission. I am not coming to Viksit Bharat much more detail. Mission for Viksit Bharat, you know that Digital India, Namami Gange, National Green Hydrogen System, Renewable Energy, Semiconductor Industry, Make in India, all these part of Viksit Bharat 2047. If you are able to achieve Renewable Energy Mission, Semiconductor Industry Mission, only Make in India Mission, Make in India मतलब रमन गॉड का नोबेल प्राइज इन इंडिया, लेकिन हम लोग रमन खरीदते कहाँ से हैं, फॉरेन से, फ्रांस से, वहां से, जापान से। अभी मेक इन इंडिया के बाद इंडिया में भी स्पेक्ट्रोमीटर बनना शुरू हो गया। तो दिस इज द इम्पोर्टेंट कि मेक इन इंडिया वी कैन मेक द डिवाइस इन द इंडिया, नॉट फोकसिंग इन द एक्सपोर्टिंग ऑफ द इंस्ट्रूमेंट। मेक इन इंडिया कैन बी आल्सो achieved by the Raman spectroscopy technique and renewable energy more exploration. Now you can see what is the role of Raman and nanomaterial in the renewable energy. So this is the things. Now I will finish my presentation. Viksit Bharat role I am not going to, because air pollution detect any hazardous material using the Raman, because I told you at nano substrate how nano substrate you can put your hazardous element and detect your molecule at the level of nano to picomolar as a detector. So this is the things. So now I will conclude. Thank you very much. If you have doubt, please ask questions. This is good question. She is asking what types of nano substrate we have to select. ओके, बिकॉज तो पहला चीज हमको क्या देखना है, रमन सिग्नल कैन बी इनहांस्ड ओनली बाय प्लाज्मोनिक नैनोमटेरियल. प्लाज्मोनिक मींस मेटल नैनो पार्टिकल. मेटल कंटेनिंग नैनो पार्टिकल हैव लार्जर प्लाज्मोनिक बिहेवियर. तो हमको क्या करते हैं, मेटल नैनो पार्टिकल हैव फ्री इलेक्ट्रॉन. तो जनरली सिल्वर, गोल्ड, कॉपर, दे हैव स्ट्रांग रेजोनेंस इफेक्ट विद योर रमन सिग्नल. तो हम मेटल नैनो पार्टिकल को ज्यादा यूज करते हैं. But nowadays people are also using graphene and particular quantum dot for surface enhancement. लेकिन मेटल नैनो पार्टिकल है लार्जेस्ट इनहांसमेंट फैक्टर. क्यों होता है? क्योंकि लेजर लाइट जैसे रमन आएगा, now your atom, your metal electrons are there, collective oscillations of electron known as plasma. Now plasma जैसे ये रेजोनेंस होगा ना इस लाइट से, इसकी इंटेंसिटी बढ़ा देगा. We call it electromagnetic enhancement. तो जनरली मेटल बेस्ड नैनो मटेरियल हैव स्ट्रांग इफेक्ट. Any more questions? Drawback. She is asking about the drawback of SCRM. Every instrument has some drawback. Drawback is reproducibility. Some people are saying, and getting the Raman signal with nanomaterial is not good. Raman has some drawback about the fluorescence. लेकिन सर्फ में वो नहीं है, क्योंकि रमन क्या क्या है, रमन का दुश्मन है फ्लोरोसेंस. फ्लोरोसेंस मतलब इस मटेरियल गेट ऑल द एनर्जी एब्जॉर्ब बाय योर मॉलिक्यूल, वी कॉल इट फ्लोरोसेंस. तो एब्जॉर्ब हो गया तो रेडिएशन नहीं होगा, रेडिएशन नहीं होगा, सिग्नल नहीं आएगा. तो रमन है क्लियर अपोजिट टू फ्लोरोसेंस. तभी क्या करते हैं, फ्लोरोसेंस का अपोजिट है. लेकिन देयर आर सर्टेन चॉइस, यू कैन चेंज रमन लेजर लाइट. क्योंकि लाइट रमन कैसे आ रहा है, कोई भी लेजर लाइट यूज करिए. रमन साहब ने मरकरी लैंप से रमन का सिग्नल खोज किया था, बट नाउ द लेजर लाइट इज देयर. लेजर लाइट हैव अ लॉट ऑफ फ्रीक्वेंसीज, यू कैन चेंज एंड यू कैन. लेकिन सरफेस इनहांस्ड स्पेक्ट्रम फ्लोरोसेंस कैन बी क्वेंच्ड. इसका एक ही है ड्रॉबैक, कुछ लोग कहते हैं इसका रीप्रोड्यूसिबिलिटी. रीप्रोड्यूसिबिलिटी इज इंपॉर्टेंट. ऐसा नहीं कि एक बार डिटेक्ट किया दूसरी बार किया तो नहीं आना चाहिए, 10 बार करें तो 10 बार एक रिजल्ट आना चाहिए. दिस इज सम ड्रॉबैक. That's why he said very less sample effect. He is asking कि sample prepare कैसे करते हैं. As I told you, my first line is that every material, because I am physics but I am working in school of nanoscience. तो nanoscience में हम लोग यही पहले पूरा पढ़ाते ही हैं, पूरा सिलेबस ही MSc में. आपको every material can be shrunk into nano form. पहला चीज. क्यों nano आया? Surface property, surface to volume ratio increased highly. And every material can be shrunk into nanomaterial. There are two approaches: top-down approach and bottom-up approach. Top-down, larger particle can be crushed into smaller particles. Generally, engineer or industry using top-down particle. Bottom-up का मतलब होता है छोटे से बड़े की तरह. मतलब आपका जैसे आपने स्टार्ट लिया, गोल्ड नैनो पार्टिकल सॉल्यूशन बनाई, जानते हैं ना, हॉट प्लेट बीकर में रखिए वाटर एनवायरनमेंट में, और उसके बाद क्या करना है, 10 मिनट वो होगा और एक रिड्यूसिंग एजेंट डालते हैं, मींस HAuCl4. व्हाट इज द वैलेंसी ऑफ AU? AU वैलेंसी इज 3 प्लस, H का प्लस 1, Cl4 मतलब -4, AU का वैलेंसी क्या हुआ, +3. इन नैनो फॉर्म +3 शुड बी कन्वर्टेड इनटू AU0 फॉर्म. तो जैसे हॉट प्लेट पे रखा, 10 मिनट बाद हम उसमें एक रिड्यूसिंग एजेंट डालते हैं, ड्रॉप बाय यूजिंग द, ठीक है. एक ड्रॉप जैसे ही डालेंगे आप, येलो कलर तो तुरंत मरगेंडा कलर हो जाएगा. जैसे वो कलर आया तुरंत कहेंगे कि गोल्ड नैनो पार्टिकल स्टार्टेड टू प्रिपेयर. और यूवी पहले कहीं भी जाने अच्छा है, यूवी करेंगे. यूवी में 550 नैनोमीटर पे पीक आया. फिर मॉर्फोलॉजी, लाइक व्हाट इज द मॉर्फोलॉजी, आइदर इट इज नैनो रॉड और स्फीयर, यू कैन कैरेक्टराइज बाय सेम एंड टेबल. अब यही बढ़ गया, यही आपने जाकर जो मॉलिक्यूल है, इस मॉलिक्यूल का एक सब्सट्रेट बना लिए, इसी के ऊपर आपको वो डिटेक्ट करना है. ठीक है. मेथड बहुत सारे हैं, फोर मेथड, hydrothermal method, whatever I am saying, metal nanoparticle is chemical reduction method. Chemical method. In every laboratory, within 30 minutes you can make the nanomaterial. That's why it is a research. This technique, मान लीजिए कोई सेंसर बनाया कि माइक्रोन लेवल तक सेंस कर रहा है इस मटेरियल को. रिसर्च क्या है? व्हाट इज द रिसर्च? Research is not new innovation. Means innovation, whatever people have done, we are starting after literature review, we are starting from that level. तो आपने माइक्रो लेवल डिटेक्ट किया है, but now I am trying to detect in nanomolar. तो हम इसीलिए रिसर्च करते हैं, अगर अच्छा होगा तो और अच्छा रिजल्ट है। हम कैसे करते हैं? पहले हमने 10 मोलर देखा आ रहा है, 10 मोलर तक आ रहा है, अब हमको ऑप्टिमाइज करना है कि हम कैसे इसको 10 मोलर कर दें। फिर लिटरेचर में बोलेंगे हमने नैनो मोलर किया, आपका पेपर 10 इम्पैक्ट 15 इम्पैक्ट में पब्लिश होगा। कैसे करेंगे? There are various choice. You can optimize the nano substrate. यही रिसर्च है, आपको प्ले करना है। हमने ये बनाया है, उससे देखा कि -6 तक आ रहा है, नहीं आ रहा है इसके ऊपर, आप उसी नैनो में थोड़ा मॉडिफाई करिए, बाइमेटालिक नैनो बनाइए या थोड़ा सा और ऑप्टिमाइज करके देखिए, उसको नैनो मोलर गया, नैनो मोलर तक पीक आ गया। इट विल डिसाइड कि हाउ यू कैन अप्लाई। अंतिम सिग्नल कहां तक सिग्नल आ रहा है, वही सेंसर होगा। यही हुआ ना? Question is that how can make the portable Raman device and how it हमने बोला कि